Hello students, next topic in MOCS is set theory. Set theory is most fundamental concept used in various disciplines, particularly in modern mathematics. Knowledge of set theory is essential to establish the concepts of relations, ordering, mappings. Okay, sets are used to group the objects together. Okay, see the definition of set. Set theory. A set is a collection of well-defined objects. Okay, a collection of well-defined objects is called a set. Is called a set. Okay, the objects in a set, the objects are called elements or members. Okay, now the objects in the set are called elements or members. Okay, see the example. The set of all even integers. Okay. The set of all people living in a city. The set of all people living in a city. Okay, these are examples of a set. Okay. Notation for sets. Notation. Now capital letters A, B, C and so on, X, Y, Z. Capital letters will be used to denote the sets. Will be used to denote the sets. Okay. If an element X belongs to a set A, if an element X belongs to a set A, then we can write X belongs to A. X belongs to A. Okay. Next, description of sets. A set can be specified in two ways: tabular form and set builder form. Okay, tabular form means a set can be defined by listing its members. Okay, by listing its elements or members. For example, 2, 4, 6, 8, 10. Okay. Next, set builder form. Set builder form means a set can be defined by stating the characteristics that its elements must satisfy. Okay. By stating the characteristics that its elements must satisfy. Okay, for example, X such that X is an odd integer. This is set builder form. Okay, by stating the characteristic of its elements, X such that X is an odd integer. This is set builder form. Okay. Next definition, null set. Null set means it doesn't contain any element. Okay, a set which doesn't contain any element is called a null set or empty set. It's called a null set or empty set and is denoted by phi or empty set. Okay. Next definition, universal set. Universal set. A set is said to be universal set. A set is said to be universal set if it contains every set under discussion. Okay, if it contains every set under discussion. Okay, for example, in throwing a dice, the universal set is 1, 2, 3, 4, 5, 6. Okay, this is an example of universal set. Next definition, subset or set inclusion. Okay, let A comma B be two sets. If every element of A is an element of B, then we say that A is a subset of B. Okay, if every element of A is an element of B, then A is called subset of B. A is called subset of B, or A is included in B. A is included in B. We denote this by like this. Read as A is subset of B or A is included in B. Okay. For example, let A equal to 1, 2, 3, 4. B equal to 6, 7. B equal to 1, 2, 3, 4, 5, 6, 7. Then clearly A is subset of B. Since every element of A is in B, okay, hence A is subset of B. Okay. See the properties of subsets. A is subset of A. That means every set is subset of itself. Okay. If A is subset of B and B is subset of A, B is subset of C, then A is subset of C. Okay. This is known as transfer property. Okay. If A is subset of B and B is subset of C, then A is subset of C. Okay. And if A is subset of B and B is subset of A, then A equal to B. Okay. Next definition, proper subset. Proper subset. That means strictly subset. Okay. A is said to be a proper subset of a set B if first A is subset of B, if A A is a subset of B, and there exists an element in B which is not in A. Okay, and there exists an element in B that is not in A. Okay, see for example, A equal to 1 3 5, B equal to 1 3 5 7 9, suppose. Okay, then A is proper subset of B. A is, we use this notation for proper subset, strictly subset. Okay, A is proper subset of B. Observe these two sets. A is 1 3 5, B is 1 3 5 7 9. Okay, here 7 9 are not in A, and every element of A is in B. First A is subset of B, and there exists an element in B which is not in A, and hence A is proper subset of B. Okay, this is the notation for proper subset, right? Next, finite and infinite sets. Finite and infinite sets. A set is said to be finite if it contains finite number of elements. If it contains finite number of elements. Okay, a set is said to be infinite. A set is said to be infinite if it is not finite. That means it contains infinite number of elements. Okay. If it is not finite, that is, it contains infinite number of elements. Infinite number of elements. Okay. Understand finite and infinite sets. Next, power set. This is collection of all subsets of a set is called power set of that set. Okay. Collection of all subsets of a set A is called the power set of A, and is denoted by P of A, power set of A, or 2 power A. Okay? If A contains n elements, then its power set P of A has 2 power n elements. Because of this reason, we denote the power set by 2 power A also. Okay. Next definition, Venn diagrams. The diagrams used to represent sets in a simple manner are called Venn diagrams. Okay. The diagrams which are used to represent sets in a simple manner are called Venn diagrams. Venn diagrams may be used to denote the relationship between two or more sets. Okay. For example, X is subset of Y. We can denote by Venn diagram. U is the universal set. This is the set Y, and this is the set X. Okay. Now here X is subset of Y. Okay. This is the set X which is included in Y. This is the set Y. X is included in Y. This X is subset of Y. Okay. Next definition: disjoint sets. Disjoint sets. Two sets A and B are said to be disjoint. Are said to be disjoint if there is no common element. If there is no common element between A and B, between A and B. If A and B have no common elements, then they are said to be disjoint sets. Okay. See, for example, A equal to 1, 2, 3, 4. B equal to 5, 6, 7, 8. Observe A and B. They don't have common elements, and hence A, comma B are disjoint. You see the Venn diagram for disjoint sets. This is the universal set. This is the set A, and this is the set B. They don't have common elements, right? And hence these are disjoint sets. Okay. This is the Venn diagram for disjoint sets. Next, operation on sets. Operations on sets. First one, union of sets. Union of sets. Let A comma B be two sets. Then the union of A and B is the set of all elements that are members of A or B or both, and is denoted by A union B. The union of A and B is denoted by A union B. That is the set of X such that X belongs to A or X belongs to B. Okay. See the example. Let A equal to 1, 2, 3, 4. B equal to 4, 5, 6, 7. Then A union B equal to 1, 2, 3, 4, 5, 6, 7. Okay. This is A union B. See the Venn diagram of A union B. This is the universal set U. This is the set A. And this is the set B. Now see A union B. The set of all elements of A or B or both. That means this is A union B. Okay. This is the Venn diagram for A union B. See the properties of union. Properties. A union A is equal to A. A union 5 is equal to A. Next, A union U. U means universal set is equal to U. Next, A A is subset of A union B, and also B is subset of A union B. Next, A union B is subset of B union A. Sorry, A union B equal to B union A. The last one is A union B union C is equal to A union B union C. Okay? This is commutative property. And this is associative. Okay, these are some properties of union. Next definition: intersection of two sets. Intersection. Okay. Let A and B be two sets. Then the intersection of A and B is the set of all elements that are common in both A and B, and is denoted by A intersection B. Okay, that means common elements in A and B. X such that X belongs to A and X belongs to B. Okay, this is the intersection of A and B. See an example: A equal to 1, 2, 3, 4. B equal to 3, 4, 5, 6. Then what is A intersection B? The common elements. That means 3, 4. 3, 4 are the common elements in A and B, and hence this is A intersection B. Now see the Venn diagram for A intersection B. This is the universal set. This is the set A, and this is the set B. A intersection B means the common elements in A and B. That means this is A intersection B. Okay, no? This is the Venn diagram for A intersection B. Okay. Next, properties of intersection. Properties. A intersection A is equal to A. A intersection 5. 5 means empty set. Is equal to 5 empty set. A intersection U. U means universal set. Is equal to A. Next, A intersection B is subset of A. A intersection B is subset of B. Next, A intersection B is equal to B intersection A. That means intersection is also commutative. Okay. A intersection B intersection C is equal to A intersection B intersection C. This is associative. Okay. Commutative property, and this is associative. Okay. Okay, students. Thank you so much for watching. See you in the next video.